So here is another question. At the beginning of 2012, a lake contains 200 fish. So that will be our U1. The number of fish in the lake is expected to increase at a rate of 5% per year. So that's the growth rate. So our common ratio will be 1.05. What will be the number of fish in the lake at the beginning of 2015? Now, I'll use this formula that I had established previously. So the population after n plus 1 years will be equal to U1 R to power n. So from 2012 to 2015, that is 3 years. So n is equals to 3. So the number of fish after 3 years will be 200 into bracket 1.05 to the power 3. And that will be 231.525 from your calculators. If you want to check, this is approximately equal to 232. Because you're talking about the number of fish, it can't be a whole number. Here is another example. The population of a city is 275,000 people. So that will be my U1. The population is increasing at the rate of 3.1% per year. So R will be 1.031. Assuming the population continues to increase at this rate, how long will it take for the population of the city to reach 500,000 people? So I'll again use this formula. The population after n plus 1 years will be given by that. So if I substitute in whatever that I have from this question, I'll end up with 275,000 into 1.031 to power n. But we want to find n when this is equal to 500,000. So we want to solve for this equation here. Find the value of n when the left hand side is equal to the right hand side. Now there is a program on your calculator that can solve this. It's called solve. So we are going to use solve. I'll show you how to do this, but I just want to rearrange this to show you how we'll plug that in the calculator. So that will be 275,000, 1.031 to power n. In the calculator, we'll plug in x, not n. So to power x. And then we'll bring whatever is on the right hand to the right hand side to the left. So 500,000, and then that's how we'll plug in the calculator. All right. It doesn't make sense here, but that's how the calculator is programmed. So we just need to plug in the way it is. This is what I mean. So if you go on your calculator, go on to catalog. So second 0, then you'll get the catalog. To go to solve, press S, which is above ln, and if you scroll down, you'll get solve, which is here. Now what I want to plug in my calculator is this. So 275,000 into bracket 1.031 to power x, okay, minus 500,000 and then x and then 0. Okay, so you can see how plugged exactly the way it is here. Okay, and then if you press enter, you should be able to get that value. So basically the solution for this equation here, the one that's in green, will be equal to n is equal to 19.58. There are many ways on how you can solve this equation. You can use logarithms, you can use graphs on your calculator, but I'm just showing you an alternative way. You know, it works sometimes, so this is also another way on how you can solve that. And that's it. So let's look at this last question. A series has the formula Sn is that the sum of n terms is that. Find the values of S1, S2, and S3. You know, the sum of the first two terms and first three terms. So S1 will be, we plug 1 in place of n. So that will be 2, 1 plus 2 minus 4, which will be 2 cubed minus 4, which is just 4. S2 will be 2, 2 plus 2 minus 4, which is 2 to the power 4 minus 4, which will give us 12. S3 will be 2, 3 plus 2 minus 4, which will be equal to 2 to the power 5 minus 4, which will be 28. Okay, so B, they're asking us to find the value of the first term. Now the first term will just be the sum of the first term, because the sum of the first term is just the first term, and that will be 4. The second term will be the first of the first two terms minus the sum of the first term, which will be 12 minus 4, and that gives us 8. And then the third term will be the sum of the first three terms minus the sum of the first two terms, which will be 28 minus 12, which gives us 16. Okay, so find the expression for the nth term. Now, before you find the expression for the nth term, let's try and rewrite what our sequence looks like. So the first term is 4, the second term is 8, the third term is 16. So by inspecting, we can see that if I want to get the second term, I have to multiply the first term by 2. If I want to get the third term, I have to multiply the second term by 2. So it is a geometric series. And in this geometric series, of course, you know that the first term is 4, the common ratio is 2. So the nth term will be, we know that the nth term for any geometric series is given by that. So I'll just plug in whatever I have for these parameters. So the first term is 4, common ratio is 2, n minus 1.
and that is the anthem.